Okay, today we're going to take a look at the derivative of e to the x. So let's go ahead and start. Learning goal. Students will be able to take the derivative of e to the x. Now, fortunately for us, in earlier videos I introduced e to the x. It's a nice little function to take the derivative of. And so hopefully this video will just be a review. We are going to take the chain rule here. So if you don't recall what the chain rule is, basically if I have a function inside of a function, which I will in a second, I simply, when I take the derivative, I take the derivative of the whole thing times the derivative of the inside. Okay, so some other things you need to know. So differentiation rules, basically the derivative of e to the x is e to the x, and the derivative of e to the u is e to the u. That makes it really nice. However, if it's not in this notation, meaning if you have something other than e to the x power, you have to probably use chain rule. Okay, example 1. Let me grab Mr. Blue. And looking at this, just scanning it real quick, it looks like I have a product rule, meaning a function times a function. So y prime is equal to, now if you don't remember what product rule was, basically it was like this. If you have a function times a function, and I'm taking the derivative, that makes the derivative of the first times the second function plus the derivative of the second function times the first. So that's what I'm going to apply right now. So derivative of x makes 1 times e to the x plus the derivative of e to the x is just e to the x times x, and you're done. Yeah, you can factor out an e to the x and rewrite it as e to the x times the quantity 1 plus x, but it's the same thing. Okay, let me grab a different color here, Mr. Red. Okay, just looking at this, you have e to the 2x minus 1 power. We're going to need to use a little bit of chain rule. Remember what chain rule said is this. If you have a function within a function, and if you take the derivative, you basically take the derivative of the whole thing times the derivative of the inside. Okay, so let's give it a go. Y prime is equal to, okay, derivative of the whole thing is just going to be e to the 2x minus 1 power. Derivative of the inside, derivative of 2x minus 1 is just going to be 2. Done. That's how easy it is. Alright, let's go to another one. Example 2. Find the derivative of each function. The notation we're going to have is f prime of t. Alright, no worries. Let's go ahead and start. It's going to be a little bit of chain rule. F prime of t is equal to, okay, derivative of the whole thing just makes e to the negative 3t. Derivative of the inside, well, the inside is negative 3 over t. So I have to rewrite this a little bit. Remember, for derivatives, we want to make sure that we have all of our variables in the numerator. So I can rewrite this as negative 3t to the negative first. Now if I take the derivative, that makes positive 3t to the negative second. If I rewrite it, that's 3 over t to the second. So this would be 3 over t to the second, and you're done. That's your chain rule. Okay, let's do the next one. Now, once again, to take the derivative, we want to make sure that we have everything in the numerator. So before I even do that, let me rewrite e to the negative t. If I take the derivative, I get f prime of t is equal to, in this case, the derivative of the whole thing is just e to the negative t. Derivative of the inside is just negative 1. Now, in earlier videos, I do chain rule another way. I don't just use basically the formula. I actually would do it this way. So, just to refresh your memory, I would let u equal the inside. Now, the inside is negative t. I then would take the derivative, du is equal to negative dt. I then rewrite it, y is equal to e to the u. I take the derivative, dy is equal to e to the u du. My favorite part, I plug all the junk back in. So dy is equal to e to the negative t, and du we said was negative dt. Divide both sides just by dt. And, oh, wrong thing. I got to cross the equal sign here. Alright, no worries. So divide both sides by dt. We get dy over dt is equal to negative e to the negative t. So notice we get the same answer. The only difference is this right-hand side in green, this will help you with implicit and later on when we integrate and use U substitution. So I prefer the right side, but a lot of you guys are working just with the formula. So alright, let me grab a different color, Mr. Blue. So this looks like to me a little bit of chain rule, a little bit of product rule. So y prime is equal to, okay, derivative of the first is cosine x times the second, e to the 2x, plus derivative of the second looks like this, e to the 2x times 2, and then you multiply the first function, so sine x, and there we go. A little bit of chain rule, a little bit of product rule. Hope you're finding this pretty easy. Okay, so on the next one, what you want to do here is this. We can use chain rule again, but let's really take a look at this. Let's see if we know anything about e and ln. Now, they're inverses of each other, so meaning if you have ln of, let's say, e to the x, because they're inverses, that just generates, and that's a function within a function, x. And the same token, if I have e to the ln of x, that just generates x because they're inverses. So before I even do any math, I could rewrite this as just x, and the derivative of x is just going to be 1. So y prime could be equal to 1. Kind of a shorthand trick. I just used some algebra to simplify. Now if you wanted to use chain rule as is, we can do that. Y prime is equal to, okay, derivative of the whole thing is just e to the ln x, and then times the derivative inside, which just makes 1 over x. Now remember that the property still stands true. This right here is just x. So we get 1 over x times x, which just makes 1. So even when we use the chain rule and not the shortcut, we get 1. Okay, last one looks like a little bit of quotient rule. If you don't remember what quotient rule look like, it's f over g. And if I take the derivative, I basically get the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. Okay, let's do it. F prime of t is equal to e to the t times t squared minus grouping symbol 2t times e to the t all over the bottom squared. So t squared squared. Okay, that's all the time we have on this video, but let's see if we met our learning goal. Students will be able to take the derivative of e to the x. If you're not able to yet, I know you're on your way. I'll see you in the next video.